Hi guys, welcome back to Hub. In today's video, we're going to be talking about load balancer, right? What is a load balancer? Why do we need it? This again, load balancer is a very common question these days, among network engineers for basically any sort of interview, right? So the most common question that they'll ask you is, have you worked basically with a load balancer before? And when you say yes, this next question is, okay, how do you define one? How do you define a load balancer? Right. So the easiest way to define a load balancer would basically be, any device, any network device, that basically helps you balance your load across your backend servers or across your database servers, whatever. Right. This is the simplest, easiest, definition. And after that, when you basically start understanding it, and you basically once you start get the grasp of it, it'll be pretty easy to understand, right? So we'll basically start with the definition here. A load balancer is a device or software application that distributes network or application traffic across multiple servers, right? This distribution ensures optimal resource optimization, improve performance, and increase stability, right? So now let me just uh, go through this. Then we'll discuss how load balancers work. Right, this is again an introduction video. Right, we'll have a detailed one on this. So basically, what we're doing is initially we're just covering a whole lot of topics, basics, so that you are clear with the idea, and then we'll deep dive into it individually. So, excuse me. So the question is, what is a load balancer? How does it work? Right. So this right here is your load balancer. Right. So load balancer, traffic reception. The load balancer receives incoming traffic from the client. So this right here is your client, right? You send a request that I want to basically access a web resource, right? Now these two are web resource. This is your SQL database, just for example. So you basically want data either from this one or from this one, right? So load distribution. The load balancer basically distributes the traffic across multiple servers based on specific algorithms. This part right here, this you will need to understand, this we will discuss. What are these algorithms on which the load balancer works, right? Then we have health checks. The load balancer continuously monitors the health of the backend servers. This is a good part. This again we'll discuss in the end, not here. So right now we're just trying to understand how the load balancer works, right? How does it actually work and how it basically distributes the load, right? Then traffic redirection. If a service fails, the load balancer redirects traffic to the healthy servers, right? These two topics will be cleared. So basically now let's start with understanding the flow. So basically what you do is you basically request, right, traffic. So you're in your office or you're doing, work from home, basically where you connect or to your company's VPN, right? And then you try to access a particular website, particular web server, whatnot, right? So eventually the data will be stored somewhere, right? So if you're accessing a web resource, it will be a web server. If you're accessing some sort of database, SQL or whatever, right? It will be a SQL database or we have databases like multiple databases, right? Application servers, database servers, web servers, right? Basically categorized into three parts. So yeah, coming back. So you request for some traffic that I need to access something. It comes to the load balancer. Now the load balancer has access to two web servers. Now for this particular example, we have two web servers. So what the load balancer will do is, as per the algorithm that you have set, right? As per the algorithm that you have set on the load balancer, it will redirect traffic to either this load balancer or this load balancer, right? So now how does it help us? Right, coming back to the simplest question of all, why do we need a load balancer? It will either transfer to this or this. I can directly redirect traffic. Why do I need a load balancer? Now, where the load balancer comes in help in the basics of understanding would be consider this one, right? There's just a client, right? This is just your router and this is your database server. So just one client, you're fetching one request, right? Doesn't matter. Now you have two clients, right? Doesn't matter again. Now you have three clients. So this SQL server or this database server, this web server will have some sort of limit. Definitely, right? Nothing is, unlimited, basically, right? So now you make it x 500. 3x 500 is 1500. Now you have 1500 users accessing multiple things, making connections with multiple servers. What will happen? This is now the limit was 500. Now it has, what do we say? It has failed. Server, why do we say the server has crashed? Right? You're watching something on the internet, on any sort of website or YouTube or something. Right? The server has crashed. The server has crashed means either the server is down, right? Because there are a lot of users, or something has happened with the server, right? Whatnot, any security breach or whatnot, or the physical device is dead. But the most common reason is overcrowd. Now, when we use the term overcrowd, it means that limit or threshold has reached, right? So once that limit or threshold is reached, you know, it cannot take any more. The CPU starts rising, right? The memory goes down, the space goes down. Now it cannot log traffic. So it cannot log traffic, it will not let you connect. The CPU has gone up, the temperature has also gone up. There are n number of things that happen in the backend, and then you say that, oh, I'm not able to connect, right? So to solve this problem, what we do is we connect a load balancer right here. So even if it's just one server, it will say that maximum 50 users are able to connect or 500 users. Above that, it will not let you connect. It will give you an error. Right now, it's your network admin who's supposed to basically put licenses here, right, and make sure the backend web server, is equipped to handle this much traffic. Now consider this one. This again has a license of 500. This again has a license of 500, right? Not one single device is overcrowded. You send some traffic here, you send some traffic here, then you send some traffic again here, then send some traffic again here based on your algorithm. Not both of these are crowded anymore, right? So if you keep sending traffic to one device, it will definitely get overcrowded. And then threshold gets reached, CPU high, memory low, space low, and then no connections whatsoever, right? So this is a simple, way in which a load balancer works. It helps you distribute the traffic, right? It has multiple algorithms. Simplest one is RR. We call it RR in networking terms, but it's basically round robin. Round robin is one traffic I'll send to this server, second traffic I'll send to this one, third traffic I'll send to this one, fourth traffic I'll send to this one. Right, so I'll make sure both of them have equal traffic, and not one device is basically overwhelmed. Right, that is the way basic round robin works. Now there are multiple things actually. If you take into account of a load balancer, which is an L7 load balancer, basically there are two type of load balancers, L4 and L7. L4 basically works on IP address, L7 works on application URL, right, applications and all of that. So traffic is basically distributed based on your application URL, URLs, applications, etc. A number of things. And L4 is basically wherein your traffic is distributed, right, based on the IP address, right, and your port numbers. Right, these are two things that you need to keep in mind. Right, rest is pretty simple. Load balancer is a device which will help you redistribute your traffic, right, so that no one device is overwhelmed and your network connectivity is optimal and very smooth. Simple as that. Right. Now, there was another thing which we were saying, health checks and traffic redirection, right? This we'll cover in the end, right? Before that, let's cover the rest of the topics. Now, what are the rest of the topics? We say that, you know, what are the balancing algorithms? First one, round robin. Distribute traffic evenly across servers. That is what I said, right? Basically, one, two, three, four. Got it? Equal traffic. This is anyway SQL server, so it doesn't matter. Right? If you want to access something from the SQL server, it will just send it to the SQL server directly. So the web servers, Web 1 and Web 2, will not be, basically requested for any traffic. Right? The second one is least connection. What it will do is, if web server first, right? We did round robin, just for example, but the clients from web server 2 are not accessing anything anymore. So these have like 5 connections, like the web 2 has client 5 connections, web 1 has 10. So as per least connections, right, even if it's round robin for web 1, it is supposed to get traffic, but it will not go there. If you have least connections on, it'll send to web server 2 with the least number of connections, right? Third is least response time. Now the now it's not just about redirecting traffic or distributing traffic. It is main about secure, faster redistribute, right? All these three things. Like authentication is not just about A, it's about AAA. Authentication, right? Authorization, accounting, right? So least response time. Directs traffic to the server with shortest response time. So if I'm sending a request here and if it is responding back to me in 3 seconds, 3 seconds actually way too much, let's just say 3 milliseconds, and this one is responding back to me in 5 milliseconds, I'll choose this one because I want my clients to get access to the application faster, right? So that is another point, right? The next one is weighted round robin, right? It is again round robin, but it depends on the server capacity or other weighing factors. You also have a weighing ratio. You can just put weighing ratio as 5 is to 3, right? 5 connections to web 1, 3 connections to web 2. Simple, you know, configuration that is actually used in real time scenarios, right? So usually it's in the ratio 5 to 3. If you give weight 5, some devices have weight in terms of, the lower the weight, more connections. Some devices have more the weight, more connections, right? Mostly it's more weight, more connections. So if we have 5 is to 3, so 5 connection is supposed to give to web 1, 3 to web 3, web 2, sorry. Right. So it will make sure that, it is always in the ratio of 5 is to 3. Right. Now the other one is least connections with the least response time. So it is just similar to you doing an AND function. Right. You want least connections and least response time. That's it. Right. If the first one has, right, 5 connections, right, and second one has 3, just for example, I have already written 10 5, doesn't matter, 5 and 3, and it is responding back to me in, this one is responding back to me in 3 milliseconds, this one is responding back to me in 2 milliseconds, right? I'll choose this one because least connections and least response time. Got it? Response time is basically the time it takes for the server to respond back to the load balancer, right? So this one, I hope it's clear. It's pretty self-explanatory. Just go through the points and you'll be able to understand. Right now, coming back to the main benefits of load balancing. So load balancing basically improves your performance, right? Since it's distributing your traffic equally, not one device is overwhelmed, and when this basically goes high, it causes physical issues. You have to replace the box. The end result is basically replacing the box or clearing cache and all of that. It interrupts the network. By the time the next device will be used, it will again be overwhelmed, and this one is also done, right? So what do? You make sure that traffic is equally distributed, right? Optimally distributed, right? So this will increase the performance, right? Reliability is increased because you'll make sure that you're very confident that your network is always up, right? Scalability is increased, I mean, allows for easy scaling of resources to meet increased demand, right? You can just easily scale. You can bring it 10 to 20. This you can bring 5 to 50. Increase your license or increase your capacity, device capacity, right? Now you can have more clients connecting to the same load balancer to the same clients, right? Scaling is increased. Now security is increased because load balancer will have multiple features for security, like SSL termination, DDoS protection. It is also has LSSL inspection, which is again a very good thing, right, for security part. So again, I hope this is clear. This is very simple, right? Since we understood the flow, then this is not much to, not much rocket science here. Now coming back to this point, this was very important, right? So now health checks. What do we mean about health checks? So health check basically means, let me just clear this one and then let me explain it. See, now, right? Let me just swipe all of this off. So these are servers, this is a client, this is a load balancer, right? So what the device will do is, so you try to make connections from here, that is fine, right? But even if you're not making connections, it will basically keep health checks here. So you have multiple options for health checks, like OS checks and all of that, right? It should be on the minimal, like host checker, right? Minimum this version, this should have an antivirus, all that, right? OS, AV, etc., etc., right? But the most simple thing is it'll always keep sending keep alives, right? Always it'll send keep alives to make sure that this device is up, right? Probably, every 3 second, right? For five iterations, it will send keep alive. If it does not get response, it will declare it as dead. Right now, this one is dead if we do not get response. So next time, it will not waste time sending traffic here and then okay, I'm not getting any response, then I have to send here, right? It will directly send traffic here. What does this do? It improves scalability. Right, it improves performance. It basically induces reliability in your whole network configuration, and your all the clients and your administrator are basically confident about the whole network of yours, right? Then we have traffic redirection. If a server fails, like I told you, if this is dead, the load balancer redirects traffic to the healthy servers. It will just redirect. So if you look at the load balancer UI, right, it will have things like this, right? It will have uh, web 1, web 2, right? For web 1, it will have a green this thing, right? Both of them will have green, but once because of the keep alive, you see that this device is not responding. It's dead. So what it'll do is it will have a red mark here stating that the device, when you hover on it or you click on it, it'll say that the device is not responded back. It's dead, right? Then you go in the back end and then you check, right? It also helps you, you know, troubleshoot your network better. Also helps you monitor your network, right? This is again a good thing. So we'll also discuss some common scenarios in regards to this, but for now, I think this is again a pretty good, topic to start or pretty good video, basically where you get insights about what is actually a load balancer, and then when you deep dive into it for load balancers like F5, it gets pretty easy for you, right? For now, this is it. I hope this was a helpful session, right? Thank you.